This is video 10 for Computer Science 3344. We are in the middle of looking at a calculating Turing machine that does everything's simple. Binary addition. This is a rewrite of stuff that was on the board last time. I snuck and did some stuff rewriting when you weren't looking. But here's where we are so far. Here's a little icon almost of the addition problem we're trying to do. We're adding 110 in binary to 101. So this is over here more for reference than anything else. That translated into an initial tape value for our Turing machine of the first operand backwards, 011. And remember, the reason we do that backwards is because we are going to actually use these bits in increasing order of magnitude, or increasing order of place value is a better way to put it. So we'll be using the 0 first of the first operand and the 1 first of the second operand. So those are going to be leftmost of the way those operands are stored on the tape. The pound sign is so that we know when we've crossed over from looking at zeros and ones of the first operand into looking at zeros and ones of the second operand, which is why we have this pound sign as well, even though there's nothing but blanks over here now. As we start depositing some bits over here, we'll have zeros and ones, and we'll need to know when we're finished looking at the second operand's bits and we've started looking at the sum bits over here. So that's completely justified to have those pound sign or hashtags or whatever you want to call them there to divide the different quantities that as they're represented on our tape. Now, all of these things, it's close to verbatim. I accidentally erased some of them before I rewrote them, so it might not be exactly the same wording, but these are the steps that we go through over and over again as we're trying to do the addition. When we start a new column, we need to remember the carry from the previous column, whether it's 0 or 1. So we start a new column, and at the very beginning, it's going to be here, and the carry-in would be 0. Then after we've got that, we'll remember what we saw here and add the carry to that, and remembering that partial sum of whatever bit was stored here in the carry-in, we'll skip over the rest of the first operand, headed over here for the pound sign. Skip over the rest of the first operand, remember that partial sum of the carry into the column and the first operand bit. So that's the second step. The third general step is we need to find, after we get to the pound sign and then we keep going, we need to find the next bit of the second operand that we haven't used. Initially, it'll be this one, the one run into first. And we add whatever we find there to the partial sum that we're remembering using the state. Everything I said so far about remembering, we're remembering it by being in a particular state that says, yes, I recall, I have seen the partial sum of 1 for this column so far. Oh, wait, I've seen a partial sum of 2. I've seen a partial sum of 0, whatever it may be. So that's how we're remembering it as we go on to the next step. So after we found this next bit of the next bit of the second operand, we've added it to the partial sum. Now we know the entire sum of the column, which we can think of as actually 2 separate bits that we treat differently. The sum of the column is going to be a 2-bit value between 0, 0, and 1, 1, all possible 2-bit combinations, where one of those represents the sum bit we need to deposit on the tape, and the other one represents the carry bit we need to bring back over here clear to the left to add at the beginning of the next column. So I got a little bit ahead again there. That's step 3, where we've added it up. We know what the column sum is. Now we keep going, go to the next blank. Pass the pound sign over there, go to the next blank, and replace it with the sum bit. That's the right-hand piece of our 2-bit column sum. Remembering the carry bit, I need to remember that by what state I'm in. That's the left-hand bit of my 2-bit column sum. So for example, if I add up the entire column and I get 1, 0, then that 1 on the left, that's the carry bit that I'm going to have to bring back and add to the next column. The 0 is the sum bit that I'm going to deposit, replacing a blank over there. It's first good. After I've done that, that's like one whole cycle. I've added up the entire column here, the 0 and the 1. I've dumped the sum bit down here, and I'm remembering a carry bit to go to the next column. Then I do the zip back to the front. Step 5 is go all the way back to start the next column, remembering that carry bit, and then we find out what the next bit is in the first operand. What's missing? Well, what's missing is the big picture of zeros and ones that I had on the board last time. But there wasn't room to do that again. You can refer back to that if these steps need a refresher for you. what I want to do is a state analysis of this. How many states do we need? And I'll go ahead and give them names. You might as well. For example, when I start over with a new column, which is this is going to be the initial state of the entire Turing machine, by the way. When I start over with a new column, how many different possibilities are there? Well, the key here is this carry. The carry can only be one bit. Either I carry a 0 to the next column, or I carry a 1 to the next column. And that's exactly what I mean by analyzing this to decide what states we need. So in purple, I guess, I'm going to put the Q0. Means that we are remembering a carry of 0. It would only seem to make sense, huh? And I need another set. I could be starting over at a column with a carry of 1 back from the far right. So that's the other possibility. And that was not a misnomer. That is the other possibility. Carry 1. So to implement step 1, I'm going to need 2 states in my Turing machine. If I'm in Q0, it means I've come all the way back to the left, and I'm remembering a carry of 0. If I'm in Q1, I'm coming all the way back to the left, and I'm remembering a carry of 1. And I don't even know what else to say about that. Now then, when I get back over here, either in Q0 or Q1, I'm going to go ahead and look at the bit that I find over here. And when I see that bit, I can go ahead and add this carry bit that I'm remembering to the bit that I'm just now scanning off the tape. That's what step 2 is. This is kind of stated backwards. We calculate this partial sum first. We add the carry bit of 0 and 1 to whatever bit we find on the tape. So, skip over the rest of the first operand, remembering this partial sum that I just now suggested that we're going to add. We're going to add the carry value and the first operand bit that we just now found. How many possibilities are there for that? Well, let's see. We're only adding 2 bits. This is not the complete column. This is the carry in from the previous column and the next bit in the first operand. We're on the top row with a little icon problem up here. So I can add a 0 carry bit to a 0, 0 to 1, or a 1 to a 0, or a 1 to a 1, right? So I can't get a lot of different possibilities with just 2 bits. I can only get a partial sum of 0, a partial sum of 1. There are actually 2 ways to get that. Carry 1, find a bit 0, carry 0, find a bit 1. The maximum I can get is 2, adding 2 1s. So I only need 3 states here, and I'll pick up where I left off. I might need a Q2, which would be what? Representing a partial sum of 0. I'll abbreviate. Part sum 0. Carry 0, found a bit 0. Q3. There's 2 ways to get to Q3. I've got a carry in of 0, find a 1, carry in of 1, find a 0. But that's a partial sum on the column so far. Partial sum of 1. But there is another possibility for this one. So for step 2, I'm going to need 3 states. I'm up to Q4. Q4 is where I have a carry in of 1 and I find a 1 on the tape. I add those together and I get a partial sum of 2. So that's where I am so far. I started off here remembering the carry, and I've added those 2 up, and I'm remembering that. Every time I do this, touch my face like I'm not supposed to, then I'm remembering some value sort of intrinsically in the state that I'm in. That's how I remember these partial sums. I'm not recording those on the tape. I'm remembering them, so when I run into another bit, I'll know what I'm supposed to add just by looking at what state I'm in. Now then, step 3. I've already got the partial sum. Now, I'm going to find the next bit of the second operand and add the partial sum to get the column sum. So for step 3, I am going to need to remember, well actually, I'm in search of the second operand. So really, I'm not ready to use the column sum yet. I'm just going to need to remember these all over again, or continue to remember these. I'm just looking for something different. So the big difference between these steps, these states, and what I'm going to have here are what they're looking for on the tape. So my Q5, I'm still going to be remembering partial sum of 1. Not of 1, of 0. And Q6, I still need to remember partial sum of 1. Man, oh man, oh man. Clumsy, clumsy. Q7, partial sum of 2. Now, it looks like this is redundant, and I certainly shouldn't need both of those, because those states represent exactly the same thing. But they don't really. If you look back at that annotated problem where I had the arrows going everywhere, this is skipping over. This is just to hang on to this until I get over here in this little promised land of the second operand. Now, I still need to remember that partial sum when I find the next bit of the second operand, and it's going to be the transition from one of these states to the next that's going to need to remember what it found in the second operand and added up to get the column sum. You got all that? So it still just needs to remember the partial sum of the column so far, which can either be 0 or 1 or 2, until it gets to this next bit of the second operand. And you can think of it as the transition of whatever state I'm in for step 3 to whatever state I'm going to be in step 4. At that point, the state here is going to need to remember the entire sum of the column. So for step 4, it turns out I actually, what? I actually do need 4 states. Can that be true? What could the column possibly be? Well, I've added 3 bits. Up to this point, what I've got is I've added the carry in, the top bit, the bottom bit. That's where I am in the grand scheme of things. Now I'm ready to dump the sum bit down here and carry the carry bit all the way back. So yes, step 4 is going to require 4 states because it's got to remember the entire column sum. And I'm going to write these in binary rather than the 0, 1, 2. And I hope I can explain why after I get it. Q8 column sum. Ugly, ugly. Q8, I'll say the column sum is 0, 0 in base 2. That's one possibility, adding up the 3 bits. Q9, column sum 0, 1. And I'm going to run out of space. That's a 9, not a Q. QQ. Q9, column sum of 01. Q10, have to write smaller. Column sum 1, 0. And finally, Q11. Oh dear, merely a coincidence here. That's an 11. Column sum 1, 1 in base 2. All of these are base 2. And the reason I wanted to write those as 2 separate bits is even though that is the numerical sum of the column, that's actually remembering 2 different values. It remembers the right-hand bit, a 0 or a 1 or a 0 or a 1, that it's going to have to use to replace a blank over here. The second bit here, that is the actual sum bit. I put a little S above there. The other bit of the column sum is the carry that we're going to have to remember in step 5 when we go all the way back to the beginning. Man, that looks like one long sentence, doesn't it? You know what? I'm going to put these in boxes. One moment, please. When you look back at this, maybe it'll be clearer where one of those stops and the next one starts. It wasn't a problem until step 4. And step 4 just had to have all those possibilities, huh? Maybe it'll help me keep them separate. That's the real reason I'm doing this. So I can visually parse this into the different cases. There. There! Now we all caught up? Now what? Well, let me read step 4 to make sure that we've got the right set of states here. Go to the next blank. Yes. Go to the blank and replace it with the sum bit. That's the right hand of these 2 bits. Remembering the carry bit. We don't write that down. We're remembering the carry bit that we're going to take back to the next column. So the left-hand bit in each one of these pairs of bits is the carry bit. And step 5, we're going to go all the way back to the start, remembering the carry. Now, going all the way back to the start, we're leaving the sum bit behind. So we don't have this many possibilities anymore. In fact, we only have 2. The only values we can carry back to start the next column are a carry in of 0 and a carry in of 1, which is carry out from this step, carry out from the previous column, carry into the next column. And that brings me up to Q12, which has carry value of 0. 12 looks suspiciously like a 10, didn't it? And then Q13, carry 1. Got a lot of states. Just imagine if this were beyond binary and we were trying to do octal addition or decimal or, heaven forbid, hexadecimal addition with hexadecimal digits on the tape. It could be done, but holy moly, we would have a lot more states. I'll let that sink in for just a second. I knew it would happen. This, trying to trace through or just describe one of these examples, it really just fills up the board. I'm going to need to reclaim at least part of this board space. I don't think I have any use for step 3 at the moment. I am not going to go directly to any of those. So I hope you got all that down. Step 3 and beyond, you're just in the way right now. Because I wanted to at least get a start at looking at little delta. Little delta has been neglected in all of this discussion. The states, the discussion of the state, that state analysis, that was just to keep up with all the different possibilities of things we would need to remember. What about little delta? If we start at the very beginning and start at Q0. Well, here we go. Little delta of Q0, and we see a 0 on the tape. Let's ponder the philosophical significance of that. If we have a 0 that we see on the tape, where Q0 means we carry in at a 0, then look what's going on. We're remembering a 0 because we're in Q0. We just now scanned this 0 on the tape. So yes, we have a partial sum of 0. And we need to head over there starting to look for the next thing going on in our addition. Partial sum of 0, look, that's Q2. So we're going to make a transition to state Q2. We're going to burn up that 0 with an X. And we're going to move to the right to start looking for the bit of the other operand. So that 0 is gone, that's now an X, and we move to the right. See how to play this game? There was another possibility. Maybe we were in state Q0, either at the very beginning or we came back and we're carrying in a 0, and we didn't see a 0, we saw a 1. Let's think about this. I'm in Q0, remembering a carry in of 0. I see a 1 instead. Then I've got a partial sum of 1. I'll make a transition to Q3. Q3, I still need to burn up that. I don't need to have a different symbol. Because like I said, we don't really care whether it was a 0 or 1 after we've used it, after we've incorporated it into the sum, because what it was before doesn't matter. So I'm going to keep that one an X and also move to a right. So far so good? What, on the other hand, now that's all possibilities. We only had 2 possibilities for what we see on the tape, and we've covered all of Q0 already. We might have, though, been starting over a new column in state Q1. If we're in Q1, we're remembering a carry-in of 1, and we might very well run into a 0. That's a possibility. If we're in state Q1, remembering a carry-in of 1, we see a 0 on the tape, then we add those together internally in the machine, in the control unit of the machine, and we have a partial sum of 1, which is Q3. Burn up that 0, leave an X behind, and move to the right. We could also, you're way ahead of me, I know, you probably already got this written down. We could have been in Q1, remembering a carrying of 1, and I spy a 1 at this position on the tape. Internally, in my Turing machine brain, I add up the one that I just now carried in and the one that I'm spying on the tape because I'm scanning it right now. I get 2. So the partial sum that I need to move on with and try to find the bit in the second operand is a partial sum of 2. So we break the seal on Q4 over here. We move to Q4, burn up the 0 or 1 we don't care, and move to the right. I believe that's all we got to do for step 1. We start a new column, remembering the carry, and we got to calculate, before we go to step 2, we got to calculate that partial sum. Add up the carry and the first operand, and that's exactly what we've done here. You don't see it, but the partial sum is more or less stored, air quotes, in the state that we're in. Q3 is remembering, yes, I've seen a 1 as the sum of all the bits I've looked at so far in this column. Q2 says, you know what, I've only seen 0 as the total so far. And Q4 says I've seen a partial sum of 2 so far. And on with the game. I could fill up the board and erase it all, and then fill up the board again and erase it all, and eventually we do all the transitions for all the states, all the mini states. How many were there? 45? I don't even remember. There was a bunch. But you know what? I don't want to take all your fun away. So instead of doing that, I'm just going to say bye-bye now, and I'll see you online.